Hello, today we'll discuss the simple DC circuits. Let us consider the series circuits. So we have the voltage source like this. We have one switch connected in series and there is a one lamp is connected in the circuit. So this circuit is called the series circuit because this is a switch, this is the lamp having some resistance, or this is a voltage source, and if this switch is closed, then the current will flow in the circuits. Okay, so this is a simple circuit. These circuits we can also represent it like this. If this lamp is having the resistor, therefore we can also, this is a voltage source, therefore this circuit we can also show like this. The lamp is having some resistor. So when the switch is connected, what will happen? The current will flow through the circuits. And when the current flows through this resistance, the heat is produced in the resistor. Okay, so either it will give heat, or if it is a lamp, it will also produce the light energy. Okay, so in this way, this is the series circuit, but the series circuit may be also like this. This is a voltage source, and now if we have to connect the two lamps in series, your circuit will be like this. Now initially there was one lamp, now there are two lamps. This is lamp 1 and this is lamp 2. Now the same current is flowing through the lamp 1 and same current is flowing through the lamp 2. But what is different? The voltage across this is now V1 and the voltage across this is now V2. Okay, so the voltage across this circuit is now different. Initially there was only one voltage. There was the voltage. So the voltage across this is V. Now when there was the only one resistor, but now, and this voltage across this is also V. But now we have connected the two lamps in the circuit. We have connected two lamps in the circuits. So what happens now? The current flowing through the circuit is same. Current flowing through the circuit is same. Same current is flowing here, same current is flowing here, but the voltage is now divided. Initially there was one lamp connected in the circuit, now there is a two lamps connected in the circuit, and therefore voltage is divided. Therefore this total voltage V is now V1 plus V2. The voltage is divided across this lamp. So this circuit we can also show like this. This is the voltage source having one switch, and here the two resistances are R1 and R2. The current I is flowing through these circuits. Now here, suppose we have to measure the current flowing through this, we require the ammeter. We require here ammeter for measuring what is the current flowing through the resistor R1. And suppose we also require what is the current flowing through the resistor R2. and this is the voltage source. So how much current is flowing through the circuit? It can be measured by the ammeter. This is ammeter. This is your voltage source, and this is your R2. How much current is flowing through the resistor R1, and this will give how much current is flowing through the resistance R2. Or we can also connect one more ammeter here. This is a suppose A1, this is A2, this is A3. This ammeter will show the how much is the current flowing at this point. This will show how much is the current flowing through at this point and in this way. So all the ammeters will show the same reading in this case, because here current I, whatever the current I is flowing at this point is the same current flowing through this at this point, and the same current is flowing through this at this point. So the current is same here, but voltage of 3 volt is get divided across the two resistors. Okay, it is get divided across the two resistors. So the voltage across the resistors R1 is V1, and voltage across the resistance is V2. So therefore the drop across V1 is nothing but what is the current? Current is I, and the resistance is R1. What is the resistance of this second lamp? It is a R2, and the current, same current is flowing through this. So this is the total voltage which we are applying across the circuit. Now this is about the series circuit. Let us consider about the parallel circuit. So parallel circuit, the same voltage source is there. In parallel circuit, two lamps are, we're considering two lamps are connected in such a fashion. So here this is the, we can call it as a circuit current, and when current is coming, and at this point the current is get divided through these two branches. First branch is I1, second branch is I2. So this is first lamp, this is second lamp. So current flowing through the first lamp is I1, current flowing through the second lamp is I2. So we have seen that the current is same in the series circuit, but the current is not same in the parallel circuit, because it is getting divided among the different branches. Suppose here are two lamps are there. Uh, we may have the three lamps in this circuit like this. So this current is again get divided. So suppose this is a I2 in this case, now this is I3. Okay, in this way, it depends upon the number of the lamps connected in parallel. So now we will consider the two lamps circuit which is connected in parallel. So suppose we have to measure the voltage across this, we require the voltmeter. What we require? We require the voltmeter. So this is voltmeter which will measure how much is the voltage. And if you have to measure the voltage across this also, we also require the voltage across this. And suppose this circuit can be also shown like this. Lamp is nothing but having some resistor, and therefore this is R1, this is R2. Current, this is a total current of the circuit. This is I1 current flowing from this. This is I2 current flowing from this. Now suppose we have to measure the current through these circuits. Then we have to draw the circuit like this. Now we have to measure the current, so we require the ammeter. We also require ammeter, one more ammeter. So this ammeter will measure the current. This ammeter will measure the current flowing through this. This ammeter will measure the current flowing through. This is R1, this is R2. Okay. So now here the current is different, but what is the voltage across this? This is the voltage V. V is the voltage across this lamp. Similarly, the voltage across this resistor is also, this is the voltage across this R1, and this is the voltage across this R. This is the voltage. Same voltage is appearing across the R1 and R2. That means in parallel circuit, the voltage across the circuit is same. Only the current is get divided. This is I1, this is I2, and this is I. So in this way, we have to measure here current. What is current high here? It is I1 plus I2. Current I is equal to I1 plus I2. And suppose we have to measure the voltage across this, then we require the voltmeter. For measuring the voltage, suppose your circuit is like this. Voltmeter is always connected across. So here we have to connect one voltmeter. Here we have to also connect one voltmeter for measuring the voltage across this resistance. This is the voltage source having some voltage. This is the current I flowing through this. Okay. So in this way we can measure the current and voltage in the given circuit. Now let us consider one circuit having the resistors R1, R2 and R3. R1, R2 and R3. Voltage applied across this is a V. Now this is a branch current is flowing through this. This current is called as the circuit current. Circuit current. Now what is the voltage across this? It is a V1. What is the voltage across this resistor? It is a V2. And what is the voltage across this? It is a V3. So what is V is the applied voltage? It is the addition of V1 plus V2 plus V3. So what is V1 here? V1 is nothing but the current flowing through this into R1. Again V2 is the current flowing through this R2, I into R2. Similarly into the this, and this is equal to V. So here we can take here I, or V is equal to IR. By using Ohm's law, we here instead of this V, we can write IR, and we can write like same. Now here we can take I common. If you take I common, so this will be get cancelled. So R is equal to R1 plus R2 plus R3. Okay. So this is the total resistance of the circuit. This is the total resistance of the circuit when the two circuits are connected in, two resistors are connected in series. Two or three resistors are connected in series, then the total resistance can be found just by adding their individual resistance. Let us consider the two resistors. This is R1, this is R2. Current I is flowing here, and voltage across this is V1. Voltage across this is V2. Now here the current I is equal to V upon R. What is this R? R is nothing but total resistance. So V upon total resistance is nothing but addition of R1 plus R2. This is equal to R. So what is the voltage drop across R1? voltage drop across R1 is I R1. This is a voltage drop across R1. I R1 is equal to V into R1 plus R2 into R1. This is the voltage drop across R1, and this is equal to what is this is equal to V1. So the current total current flowing through the circuit is I is equal to V upon R1 plus R2. Just we have multiplied here by R1. So when you multiply this by R1, so this is a voltage drop across the resistance R1. Now, hence we can write here V1 by V R1 by R1 plus R2. So in this V1 by V is equal to R1 by R1 plus R2. Therefore, this will help you. The ratio of the voltage therefore depends on the ratio of the resistances. Okay. So in this way we can find the voltage drop across the resistance. So how you can find the voltage drop across V1? Here we can find V1 is equal to total V into R1 by R1 plus R2. V1 voltage across the resistance R1, V1 is equal to V into R1 by R1 plus R2. Similarly, we have to find the voltage across the resistors R2 is equal to V2 is equal to total voltage into the resistance of that resistor divided by the sum of the two resistors. So in this way we can find the voltage drop across the series and series resistors. So let us take one example here. We'll take one example. This is R1 and this R1 is equal to R1 is 100 ohm, and calculate where to find where to find here R1. R1 where to find R2 it is given 100 ohm, and what more is given? And this voltage is given 30 volt output, and this voltage is given. Voltage across this resistance is given. This is a 10 volt. We are getting the 10 volt across this. So what is given? V2 is given. V2 is given, and we are required to find here resistance R1. So can you use this formula? Yes, we can use this formula because we know R2 here. We know R2. Okay, and we have to find this R1, and you know the total voltage. This is total voltage, and this is V2. So we can use this formula. So V2 is here 10 is equal to total voltage is 30 into R2 is given 100 divided by R1 we have to calculate plus 100. Okay, so this is given. So we can write like this: 10 upon 30 is equal to 100 by R1 plus 100, like this. So this R1 plus 100 is equal to 300 by 10. So this is a 30, and this R1, oh no, this is a 100 into 30. This 10 will come here. This will get cancelled. This is a 3000. So R1 is equal to 3000. Sorry, 300 minus 100 is equal to 200. This is ohm. So this is a R1. So in this way we can calculate the resistors across the given circuit. So here this is by using the relationship of the series circuits. Now let us come to the parallel circuit. Now in the parallel circuit, what is given? For example, we have the two resistors, they are connected in parallel. This is the voltage across, this is 110 volt. This is a circuit current, and this is a branch current going through this first branch and second branch. And the resistance is given, it is a 22 ohm and it is 44 ohm. Okay, and this is R1, it is given 22 ohm, this is R2. Okay, and we have to calculate this current, this supply current we have to calculate. Okay, so what is the voltage across this is the same. Okay, in parallel circuit voltage is same. So here what is the drop across this? V is equal to IR1. This is a drop across resistance R1. What is the drop across this resistance R2? It is I into R2. So there, from this relationship we can calculate the current flowing through this. We can calculate, where we will give the notations I1 because different currents are flowing through this. V is equal to, so we have to calculate I1. I1 is equal to V upon R1. So V is there 110 divided by 22. This is a 5 ampere. Similarly, I2 is equal to, this is I2, not I1. Current flowing through this second branch. So I2 is equal to V upon R2. It is 110 divided by, it is a 44. So it is a 2.5 ampere. So the total current is nothing but just the addition of these two currents. That is a circuit current. So the total current is now I is equal to I1 plus I2. So it is a 5 plus 2.5 is 7.5 ampere. So in this way we can find the current flowing through this different branches. Now let us consider the two resistors are connected in parallel. This R1, R2, this is the voltage which is given to the circuit. So current flowing to this is I1, this is I2, this is I. So total when two resistances are connected in parallel, the equivalent resistance is here 1 by R1 plus 1 by R2. Therefore 1 by R is equal to R2 plus R1 by R1 R2, and therefore equivalent resistance R is equal to R1 R2 by R1 plus R2. So this is when the two resistors are in parallel. Now what is the V is equal to IR. So this equivalent resistance is nothing but R1 R2 by